Hello judges, this is Team Proteominds. Our project focuses on early detection and prediction of genomic and proteomic diseases. Currently, there is no predicting method that combines both proteomic and genomic data. Moreover, current methods are very expensive and detection is only possible in the later stages. Our model is cost effective, and since detection is early, the patient can go through lesser suffering and lesser overall medical bills. Let us see the overall flow of the project. First, the data is collected and it is checked for the presence of any biomarkers. If the biomarkers are present, then the disease is detected and the report is generated. If not, the future protein interactions are predicted and the percentage of risk gets calculated and the report is generated. Let us see the actual model. UI. You can drag and drop the required file. You can see the preview, report. This is the downloaded report. As you can see, no risk has been detected in this case. We have used Streamlit for the front end and the back end development of our UI. Let us see the actual model of our project. We have chosen graph neural networks to train the model because it is a very strong model which can easily analyze the complex relation between the protein. We have cleaned and processed the dataset and converted it into a graph. We considered protein as a node and interaction as an edge. After training the model using GNN, we got 83% accuracy. In the confusion matrix, we have 52,000 true positives and 300 false positives. It is clearly indicating the well performance of a model. After the interactions are generated, we map it with the database. The database and the XML file containing biomarkers as the root. We clean and pass the database. Protein interactions and its associated gene symbols will be extracted from the database, which is then mapped with the generated interactions. After the mapping is done, a report is generated based on the result. The report tells us if a person is at a risk of getting a disease in the future or not. We intend to use HIPAA-compliant cloud for the storage of the sensitive data and blockchain technologies during the transmission of the data. Deployment of a model is highly scalable and very easy. Our model is socio-economically sustainable, having long-term benefits, and early prediction of the disease is done. The patient can now have a better quality of life. I'd like to clear a few things out. Our model can both predict and detect a disease. Detecting. So let us consider an example of Down syndrome. Most mothers do not go for this test as it is quite expensive. Our model is the best budget-friendly alternative. Most mothers do not know until birth that the baby is with Down syndrome, so the baby might be missing out on several special cares and needs. Even many other birth-related premature or low weight at birth, all this can be detected. Coming to the prediction. Suppose a person could have type 2 diabetes 10 years down the line. Our model can predict that and the person can take measures so that he might not get the disease itself, thus preventing suffering and paying high medical bills. Not just type 2 diabetes, liver diseases, myocardial infarction, prostate cancer, breast cancer, ovarian cancer, and many different kinds of cancers can all be detected well in advance. All this is possible only with the collaboration with government to make sure each and every person can access the facilities irrespective of their financial backgrounds. Our project is completely novel and has taken a never-seen approach before. Unlike existing platforms that typically focus on either genomic or proteomic data, this project uniquely integrates both to provide a more comprehensive understanding of the disease mechanisms and risk factors. Identifying potential health issues before they become symptomatic, the platform uses predictive analysis for early detection and intervention. I'd like to end with one point. We are not making a diagnosis, but rather a prediction of a diagnosis, thus building a better future for all of us.